Good day and welcome to this episode of differentiation. This is the fifth episode, and we are still under the application of differentiation. So, in this part, we are going to be dealing with rate of change and also the minimum and maximum points on the next part. So, continue from here, we are about to solve the question that has to do with radius of an hemisphere. So, it's increasing at the rate of 0.5 centimeter per second. Now, even looking at the unit already, you know what you are asked, what you are given already. So this is centimeter, that's radius per what per time. So you have been given your dRdt. So the radius increasing at a rate. So your dRdt is 0.5 centimeter per seconds. So we are asked to find the rate at which the volume of the hemisphere is increasing. So we are asked to look for V, dV, dr, right? So the volume of at which the hemisphere is increasing, that is the rate. So that would be dV dr. That's what we are looking for. So now we are dealing with volume of an hemisphere. And what is the formula for the volume of an hemisphere? That is 2 over 3 pi r cube. 2 over 3 pi r cube. So you can see now that we have v with respect to r. And when we can differentiate, that will be dv dr. Right here is dv dt. Rather, it is dv. It is rate, so it's supposed to be t, not dv dr. So now we are going to get our dv dr now, and now you multiply 3 by the coefficient. Remember the differentiation rule. So 3 will cancel 3 to remain 2. Then pi r 3 raised to power 3 minus 1, that will be square. So this is also equivalent to the area of a sphere, kind of, but it's just that the area of the sphere has 4 pi r square. So this is what we have here, and they've given us our radius. So now we can get our dv dt. So dv dt, according to function of function or chain rule, to be dv dr, which is this, multiplied by dr dt, in a way that you say that if you cancel dr dr, you still have your dv dt back. So that means you are good to go. Let's insert. You have dv dt equals, what's our dv dr? This 2 pi r, what's our r? 3, then square, multiplied by dr dt, which is 0.5, to give us, let's see what we have. Calculating that on our calculator, we're going to be having 9 pi. Yes, 9 pi, because this is 1 over 2, and 2 cancel 2, 3 square is 9. So we're having 9 pi. It is volume over time, so it's going to be centimeter cube over seconds. So that's for this. Now, volume of a sphere is increasing at the rate of this. Volume of a sphere is increasing at the rate, and you can see it is volume over time. So that will be dv dt. dv dt is what? 40.8 centimeter cube per seconds. We are now asked to calculate the three cylindrical figure, the rate at which the surface area is increasing. Now, they gave us volume, and they are asking us to look for the ADR, the ADT, because this is area with rate. So we have to look for the ADT. Now, how is it related? It's not related, because if you want to get the ADT, we are going to be needing the A, the R, and we are going to be needing the R dt. So this is the A, the R. You can't even get that one now, but we have to get this first. This one is related to this. You can get, if you are looking for dv dt, you can say dv dt is equals to dv dr dot dr dt. So you can get your volume of your sphere as a formula and then differentiate it. So from there you will get what? Dv dt. Let's solve this. Let's go into it. Now we have dv dt. Let's start from here. We have this one available, and it is the volume of a sphere. What is the volume of a sphere? That would be v. V is equals to 4 over 3 pi r cube. That's the volume of the sphere. So we can differentiate dv dr. So dv dr will be 3 multiplied by the whole of this. 3 we cancel 3 to remain 4. So that's 4 pi r square minus 1. Remember. So now I have my dv dr, I have my dv dt. Definitely I can get my dr dt. So now solving further, we say dv dt equals dv dr dt. So my main focus is to find this. That's what I'm looking for now. So since I have these two, I'll just insert them. So you have given me this one in the equation as 40.8. Then I have dv dr here, 4 into brackets pi, then brackets, the radius is 3.2 square, then multiply by dr dt. So this will come under here. It will be 48 divided 40.8 divided by this. So my dr dt, without wasting much of my time, let me calculate that. So it will be 40.8 over 4 pi 3.2 square. Let's see what we have there. We are going to be having 0.32. 0.32. It is radius over time. So that is centimeter per second. Now we have gotten this. And there's no how now we can get our dA dt, that is the rate at which the surface area is increasing. We can get that now. So now we can start using the formula dA dt equals dA dr multiplied by dr dt. How do we get our dA dr? So since we are asked to look for the area at which the surface area is increasing of the sphere, so we need to know the area of the sphere. And what's the area of the sphere? The area of the sphere is 4 pi r square. So if we differentiate the volume of a sphere, it will give you the area of the square. So the area of the square is, the area of a sphere is what? 4 pi r square, right? So now you want to differentiate it as your dA dr. You will differentiate this to get your dA dr. So it will be 2 multiplied by 4, that will be 8 pi r. 4 multiplied by 2 is 8 according to differentiation. So now you can insert your dA dt now. It will be your dA dr, that's 8 pi r. R is 3.2 multiplied by your dr dt, the one you got here, 0.32. Calculating that, we are going to be having 25.7, and it is centimeter square over seconds. So that's it for that. Remember they said 3 significant figures. So that's it for that. Now let's move to the next part. So moving to the second part, we are going to be doing a minimum and maximum point. So firstly on this note, there are many rules, but it is very simple if you can follow up to the end. It's very important. So for here, for both of them, the y dx is equals to 0 for both of them, for both maximum and minimum points. That means whatever function they give you, differentiate it and equate it to 0. From there you will have two values. You will have x is equals to this or this. So from there you will now insert each of those x's into the what? The equation given. So from there we notice that a value of y is high and a value of y is low. So that value of y that is high is for the maximum point. The low value of y is the minimum point. That's the easiest and fastest way to quickly get your maximum and minimum point, especially when you are working in an OBJ. So then if you now feel you want to know more and you want to check maybe you are more correct, you can now differentiate it twice. That's your second derivative. So you'll be saying the square y dx square, if it is this is minimum, right? If it is greater than 0, that means if your answer is positive, it is your maximum point. That's your y for this second derivative. If it is negative, is minimum. Then your second derivative here, if it is less than 0, that means if it is negative, that's when it is maximum. That's for the second derivative side. So without wasting much of our time, let's venture into this. Now according to what I said, differentiate your y equals to 0 first. So I will find the differentiation of this. That's the y dx equals to, let's differentiate this. This will be 3x squared I'm sure we are good with differentiation now. So plus this will be what? 6x. Now equate it to 0. So let's just say let the y dx equals to 0. We are following this rule, right? So if you equate that to 0, you see that we are factorizing here now because we have 3x. This 3x is common here and here. You can remove them. So you can just say 3x into brackets. It will remain only 1x here when you remove that 3x, right? So when you remove 3x from this place, what we have? You have 2, because 3x multiplied by 2 will be 6x. So equals to 0. Now I have 2x already. I have 3x equals to 0 and I have x plus 2 equals to 0. So x equals to 0 and x equals to minus 2, right? So we are good with that. Now it's now time to insert the x into my real equation, my real y, so that I can know my y. From there I will pick the high value for the maximum point and I'll pick the low value of y for the minimum point. Now let's move on. For here, now I can say at x equals to 0, that's for this one. I can insert y. Y is equals to 0 raised to power 3 plus 3 into bracket 0. All this will be what? 0, because there's no point here. Now at x raised to power minus 2, let's see what happens. Y is equals to minus 2 raised to power 3 plus 3 into bracket minus 2 raised to power 2. So let's see what happened there. Minus 2 raised to power 3, that's minus times minus times minus, right? It's still going to give us minus. Minus times minus is plus, times times minus, that will be minus again. So that will be minus what? 8 plus 3 into brackets minus 2 square, that's minus 2 times minus 2, that's what? 4, because minus will cancel minus there. So here we have minus 8 plus 12 and this is minus 4, right? We have for the first one now, I will say the x comma y is 0 comma 0, and for the second one is what? Minus 2. This is 4, this is 4, this is 4. Minus 8 plus 12 is 4. So minus 2 comma 4. Now from here now we can detect the maximum and minimum points. How? The high value, the one that has the highest value of y is what? This. So this is the maximum point. Sorry about that. This is the maximum point, and here is the minimum point because it has the lowest value of y. Now going to check more further if we are not sure yet. Let's check the second derivative. So second derivative, the square y dx square of this. So we are differentiating this again. So that will be 6x plus 6. So now at x equals to 0 and at x equals to 2 again, let's check them. So for here to be 6 into bracket 0 plus 6 is going to give me what? 6. You can see it is positive. So x for x is equals to 0, you see that it's getting positive, and that is indicating that it is minimum point. You can see if it is positive. Now let's do the second one. The square y dx square at x is equals to minus 2, that will be 6. Let's just insert it directly. Minus 2 plus 6 will give us what? This is minus 12 plus 6, right? Minus 12 plus 6, that will be what? Minus 6. You can see it is negative, and that is what the maximum point according to what I did here. So that's just it for this case. I'm going to be doing more of x intercepts, y intercepts, asymptotes and the likes in the next episode. Do well to like, share, subscribe and comment. Thank you.